Unix started being developed 50 years ago, maybe more than 50 years ago. Can you tell the story, like you describe in your new book, of how Unix was created?
If I can remember that far back, it was some while ago. So I think the gist of it is that at Bell Labs in 1969, there were a group of people who had just finished working on the Multix project, which was itself a follow-on to CTSS. So we can go back sort of an infinite regress in time, but the CTSS was a very, very, very nice time-sharing system. It was very nice to use. I actually used it as that summer I spent in Cambridge in 1966.
What was the hardware there? Right. So what's the operating system? What's the hardware there? What's the CTS look like?
So CTSS looked like kind of like a standard time-sharing system. Certainly at the time, it was the only time-sharing of note.
Let's go back to the basic. What's the time-sharing system?
Okay, in the beginning was the Word, and the Word was...
And then there was time-sharing systems.
Yeah. If we go back into, let's call it the 1950s and early 1960s, most computing was done on very big computers, physically big, although not terribly powerful by today's standards, that were maintained in very large rooms, and you used things like punch cards to write your programs on them, talk to them. So you would take a deck of cards, write your program on it, send it over a counter, hand it to an operator, and some while later back would come something that said, oh, you made a mistake, and then you'd recycle. And so it was very, very slow. So the idea of time sharing was that you take basically that same computer, but connect to it with something that looked like an electric typewriter. They could be a long distance away, it could be close. But fundamentally, what the operating system did was to give each person who was connected to it and wanting to do something a small slice of time on to do a particular job. So I might be editing a file, so I would be typing, and every time I hit a keystroke, the operating system would wake up and said, oh, he typed a character, let me remember that. And then it'd go back to doing something else. So it'd be going around and around a group of people who were trying to get something done, giving each a small slice of time and giving them each the illusion that they pretty much had the whole machine to themselves, and hence time sharing. That is, sharing the computing time resource of the computer among a number of people who are doing it.
Without the individual people being aware that there's others, in a sense. The illusion, the feeling is that the machine is your own.
Pretty much that was the idea. Yes, you had, if it were well done and if it were fast enough and other people weren't doing too much, you did have the illusion that you had the whole machine to yourself. And it was very much better than the punch card model. And so CTSS, the compatible time-sharing system, was, I think, arguably the first of these. It was done, I guess, technically in 64 or something like that. It ran on an IBM 7094, slightly modified to have twice as much memory as the norm. It had 2 banks of 32K words instead of 1. So
32K words. Yeah.
Each word was 36 bits. So call it, about 150 kilobytes times 2. So by today's standards, that's down in the noise. But at the time, that was a lot of memory, and memory was expensive. So CTSS was just a wonderful environment to work on. It was done by the people at MIT, led by Fernando Corby, who died just earlier this year, and a bunch of other folks. And then, so I spent the summer of 66 working on that, had a great time, met a lot of really nice people, and indirectly knew of people at Bell Labs who were also working on a follow-on to CTSS that was called Multix. So Multix was meant to be the system that would do everything that CTSS did, but do it better for a larger population, all the usual stuff.
Now, the actual time sharing, the scheduling, what's the algorithm that performs the scheduling? What's that look like? How much magic is there? What are the metrics? How does it all work in the beginning?
So the answer is I don't have a clue. I think the basic idea was nothing more than who all wants to get something done. Suppose that things are very quiet in the middle of the night, then I get all the time that I want. Suppose that you and I are contending at high noon for something like that, then probably the simplest algorithm is a round robin, one that gives you a bit of time, gives me a bit of time, and then we could adapt to that. Like, what are you trying to do? Are you text editing, or are you compiling or something? And we might adjust the scheduler according to things like that.
So Multix was trying to just do some of the, clean it up a little bit.
Well, it was meant to be much more than that. So Multix was the multiplexed information and computing service, and it was meant to be a very large thing that would provide computing utility, something that where you could actually think of it as just a plug in the wall service, sort of like cloud computing today.
Yeah.
Same idea, but 50 odd years earlier. And so what Multix offered was a richer operating system environment, a piece of hardware that was better designed for doing the kind of sharing of resources, and presumably lots of other things.
Do you think people at that time had the dream of what cloud computing is starting to become now, which is computing is everywhere, that you can just plug in almost, and you never know how the magic works. You just kind of plug in at your little computation that you need to perform, and it does it. Was that the dream?
I don't know where that was the dream. I wasn't part of it at that point. Remember, I was an intern for a summer. But my sense is, given that it was over 50 years ago, yeah, they had that idea that it was an information utility, that it was something where if you had a computing task to do, you could just go and do it. Now, I'm betting that they didn't have the same view of computing for the masses, let's call it, the idea that, your grandmother would be shopping on Amazon. I don't think that was part of it. But if your grandmother were a programmer, it might be very easy for her to go and use this kind of utility.
What was your dream of computers at that time? What did you see as the future of computers? Could you have predicted what computers are today, in a sense?
Oh, short answer, absolutely not. I have no clue. I'm not sure I had a dream. It was a dream job in the sense that I really enjoyed what I was doing. I was surrounded by really, really nice people. Cambridge is a very fine city to live in the summer, less so in the winter when it snows, but in the summer it was a delightful time. And so I really enjoyed all of that stuff, and I learned things. And I think the good fortune of being there for summer led me then to get a summer job at Bell Labs the following summer. And that was quite useful for the future.
So this Bell Labs is this magical, legendary place. So first of all, where is Bell Labs? And can you start talking about that journey towards Unix at Bell Labs?
Yeah, so Bell Labs is physically scattered around, at the time, scattered around New Jersey. The primary location was in a town called Murray Hill, or a location called Murray Hill. It was actually across the boundary between two small towns in New Jersey called New Providence and Berkeley Heights. Think of it as about 15, 20 miles straight west of New York City, and therefore about an hour north of here in Princeton. And at that time, it had make up a number, 3,000 or 4,000 people there, many of whom had PhDs and mostly doing physical sciences, chemistry, physics, materials kinds of things, but very strong math and rapidly growing interest in computing as people realized you could do things with computers that you might not have been able to do before. You could replace labs with computers that had worked on models of what was going on. So that was the essence of Bell Labs. And again, I wasn't a permanent employee there. That was another internship. I got lucky in internships.
I mean, if you could just linger on it a little bit, what was in the air there? Because some of the number of Nobel Prizes, the number of Turing Awards, and just legendary computer scientists that come from their inventions, including developments, including Unix, is unbelievable. So was there something special about that place?
Oh, I think there was very definitely something special. I mentioned the number of people, so a very large number of people, very highly skilled, and working in an environment where there was always something interesting to work on, because the goal of Bell Labs, which was a small part of AT&T, which provided basically the country's phone service, the goal of AT&T was to provide service for everybody, and the goal of Bell Labs was to try and make that service keep getting better, so improving service. And that meant doing research on a lot of different things, physical devices like the transistor or fiber optical cables or microwave systems, all of these things the labs worked on. And it was kind of just the beginning of real boom times in computing as well, because when I was there, I went there first in 1966. So computing was at that point fairly young. And so people were discovering that you could do lots of things with computers.
So how's Unix born?
So Multix in spite of having an enormous number of really good ideas and lots of good people working on it, fundamentally didn't live up, at least in the short run, and I think ultimately really ever, to its goal of being this information utility. It was too expensive, and certainly what was promised was delivered much too late. And so in roughly the beginning of 1969, Bell Labs pulled out of the project. The project at that point had included MIT, Bell Labs, and General Electric. General Electric made computers, so General Electric was the hardware operation. So Bell Labs, realizing this wasn't going anywhere on a timescale they cared about, pulled out of the project. And this left several people with an acquired taste for really, really nice computing environments, but no computing environment. And so they started thinking about what could you do if you were going to design a new operating system that would provide the same kind of comfortable computing as CTSS had, but also the facilities of something like Multix sort of brought forward. And so they did a lot of paper design stuff. And at the same time, Ken Thompson found what is characterized as a little used PDP-7, where he started to do experiments with file systems, just how do you store information on a computer in an efficient way. And then this famous story that his wife went away to California for 3 weeks, taking their 1-year-old son, and 3 weeks, and he sat down and wrote an operating system, which ultimately became Unix. So software productivity was good in those days.
So PDP, what's a PDP-7? So it's a piece of hardware.
Yeah, it's a piece of hardware. It was one of early machines made by Digital Equipment Corporation, DEC, and it was a mini computer, so-called. It had, I would have to look up the numbers exactly, but it had a very small amount of memory, maybe 16K, 16-bit words or something like that, relatively slow. Probably not super expensive. Maybe, again, making this up, I'd have to look it up, $100,000 or something like that.
Which is not super expensive in those days, right?
It was expensive. It was enough that you and I probably wouldn't be able to buy one, but a modest group of people could get together. But in any case, it came out, if I recall, in 1964. So by 1969, it was getting a little obsolete, and that's why it was little used.
If you can sort of comment, what do you think it's like to write an operating system like that? So that process that Ken went through in 3 weeks, because you're part of that process. You contributed a lot to Unix's early development. So what do you think it takes to do that first step, that first kind of from design to reality on the PDP?
Well, let me correct one thing. I had nothing to do with it. So I did not write it. I have never written operating system code.
Yes.
And so I don't know. Now, an operating system is simply code. And this first one wasn't very big, but it's something that lets you run processes lets you execute some kind of code that has been written. It lets you store information for periods of time so that it doesn't go away when you turn the power off or reboot or something like that. And there's a kind of a core set of tools that are technically not part of an operating system, but you probably need them. In this case, Ken wrote an assembler for the PDP-7 that worked. He needed a text editor so that he could actually create text. He had the file system stuff that he had been working on, and then the rest of it was just a way to load things, executable code, from the file system into the memory, give it control, and then recover control when it was finished or in some other way quit.
What was the code written in primarily the programming language? Was it in assembly?
Yeah, PDP-7 assembler that Ken created. These things were assembly language until probably call it 1973 or 74, something like that.
Forgive me if it's a dumb question, but it feels like a daunting task to write any kind of complex system in assembly.
Absolutely.
It feels like impossible to do any kind of what we think of as software engineering with assembly, because to work on a big picture, sort of.
I think it's hard. It's been a long time since I wrote assembly language. It is absolutely true that in assembly language, if you make a mistake, nobody tells you. There are no training wheels whatsoever. And so stuff doesn't work. Now what? And
there's no debuggers.
Well, there could be debuggers, but that's the same problem, right? How do you actually get something that will help you debug it? So part of it is an ability to see the big picture. Now, these systems were not big in the sense that today's pictures are. So the big picture was in some sense more manageable. I mean, then realistically, there's an enormous variation in the capabilities of programmers. And Ken Thompson, who did that first one, is kind of the singularity in my experience of programmers. With no disrespect to you or even to me, he's in several leagues removed.
I know there's levels. It's a fascinating thing that there are unique stars, in particular in the programming space and at a particular time. You know, the time matters too. The timing of when that person comes along,
Yeah.
and a wife does have to leave to like. There's this weird timing that happens and then all of a sudden something beautiful is created. I mean, how does it make you feel that there's a system that was created in 3 weeks, or maybe you can even say on a whim, but not really, but of course quickly, that is now, you could think of most of the computers in the world run on a Unix-like system.
Right.
What how do you if you kind of zoom from the alien perspective, if you're just observing Earth, that all of a sudden these computers took over the world and they started from this little initial seed of Unix. How does that make you feel?
It's quite surprising. And you asked earlier about prediction. The answer is no. There's no way you could predict that kind of evolution. And I don't know whether it was inevitable or just a whole sequence of blind luck. I suspect more the latter. And so I look at it and think, gee, that's kind of neat. I think the real question is, what does Ken think about that? Because he's the guy, arguably, from whom it really came. You know, tremendous contributions from Dennis Ritchie and then others around in that Bell Labs environment. But, you know, if you had to pick a single person, that would be Ken.
So you've written a new book, Unix, A History and a Memoir. Are there some memorable human stories, funny or profound, from that time that just kind of stand out?
Oh, there's a lot of them in a sense. And again, it's a question of, can you resurrect them in real time way? His memory fails. But I think part of it was that Bell Labs at the time was a very special kind of place to work, because there were a lot of interesting people and the environment was very, very open and free. It was a very cooperative environment, very friendly environment. And so if you had an interesting problem, you go and talk to somebody and they might help you with the solution. And it was a kind of a fun environment too, in which people did strange things and often tweaking the bureaucracy in one way or another.
So rebellious in certain kinds of ways.
In some ways, yeah, absolutely. I think most people didn't take too kindly to the bureaucracy, and I'm sure the bureaucracy put up with an enormous amount that they didn't really want to.